Hello and welcome to the Gestalt IT Rundown for July 20th. My name is Tom Hollingsworth, and if you were rather curious about what your lucky numbers are, if you needed some pithy saying to go along with your day, don't worry because it is National Fortune Cookie Day, and we are here to bring you all of the fortunate news coming out of the enterprise IT space. And joining me is the Zen master himself, Mr. Stephen Foskett. Stephen, it's been a couple of weeks since we've done a show together. Welcome back.
It's great to be here. Come on back next week for another fortune.
That's right. Hopefully, this week it will be something a little bit more appealing to the companies who have some forward-looking future projects in mind. We've got coverage from the cloud space, the chip space, and some spooky security stories. So let's go ahead and jump right in. Now, some of you in the audience are probably familiar with the object storage platform MinIO, and it's now available on Google Cloud Platform. You can roll your own MinIO instance in the old-fashioned way up to now, but GCP Marketplace now makes it a whole lot more attractive for businesses to be able to use MinIO. Given the focus that Kubernetes has in the Google Cloud Platform, you can expect that MinIO is probably going to be providing some great performance for any applications that you want to deploy on those. Now, Stephen, since you're the storage expert and the cloud expert around here, you've heard of MinIO before because they've been involved with our Field Day series. Why would someone want to use them in GCP?
Yeah, I think that's really the core question here. And when you ask that, let me just point out that there are actually 150,000 deployments of MinIO in GCP already. You've been able to run MinIO basically anywhere forever. In fact, that's actually one of the most attractive aspects of this piece of software. I've got it running in my table in the other room, my cloud in a table. And frankly, it's great. It works great, provides S3 compatible storage that is basically compatible enough and high featured enough that you can run basically anything on it. And that's the answer to the question of why somebody would want to run MinIO in GCP. GCP has their own object store, but it's not S3 compatible like MinIO is. And frankly, S3 protocol is where it's at. When it comes to storage applications, especially in Kubernetes, we're seeing so many things just assuming that you can have access to S3 storage from popular applications with plugins like WordPress to basically anything that anybody's going to roll their own. It just makes sense to use S3 protocol, and that's what MinIO is bringing. Of course, MinIO also brings a lot more. They have a really nice tiering aspect to the product, which allows you to have high performance for active data and lower performance for less active data, which is pretty cool in the cloud. And frankly, the big thing here is application portability. Essentially, if you're running something on Kubernetes and you need to program to a object storage protocol, having MinIO be there in GCP allows you to basically run the same thing in AWS, EKS, and GCP. It all just works. So, frankly, this is a great move. It's great to see MinIO there. Real good company, real good product. And I'm glad to see that the S3 protocol is taking over everywhere, including GCP. Tom, moving on to one of your favorite topics, the FCC. Chair Jessica Rosenworcel is ready for faster broadband, and frankly, so are we all. Specifically, she's indicated that during the next annual evaluation of the country's broadband infrastructure, she'd likely increase the minimum speed to 100 megabits down and 20 megabits up. That may sound like basic connectivity to a lot of people, but frankly, the current minimum speed of 25 and 3 is pretty much what we're getting, even in places like beautiful Hudson, Ohio, as long as you're not within range of municipal fiber. The minimum speed requirements typically come into play in low-income areas and rural communities where getting out-of-date infrastructure out of the way is a big problem. Also included in the notice of inquiry sent out is a future goal for a 1 gigabit down and 500 megabits up in a few years. That sounds pretty great. Is the FCC trying to make everything faster or just making rules that can't be followed?
So, with all due deference to the former occupant of that chair and his comically oversized coffee cup, Chairwoman Rosenworcel is actually doing something instead of talking about doing something. So I like the way that she is effectively saying, listen, service providers, I know that you leave deep fingerprints in every dime that you spend. But if you want to meet our requirements, you're going to have to spend out. Now, granted, I live in a city in a rural state, so I have both sides of it. I have relatively fast communicative technologies here. I have a cable modem, and about a block that direction, I have a fiber line that I really wish that I could get into. However, when you go out into the communities out there, you're seeing, dial not dial up, but pretty close to it. 25 is the minimum. They consider that like a lifeline service. Have you ever used 25 megabit internet on a broadband connection? I have at my in-laws house. It's terrible. It's really terrible. So what do? Well, we basically say if you want to meet our minimum specifications, you must raise the limits. And that means that you need to invest in your infrastructure. And before you think, oh, well, service providers won't do that, what is the alternative? Oh, that's right. It's 5G and LTE, which are already hitting well above 25 megabit downstream services. I mean, with 5G, you're hitting above 100 in most cases. So either the providers that are offering like AT&T, Verizon, and all of them are either going to take these service providers' money, or they're going to pressure the service providers to upgrade their infrastructure because they're being overwhelmed by customers who are dumping their local loop in favor of a mobility focused like 5G service because it's the fastest one they can get. And T-Mobile is already doing this. When you look at their in-home, basically microcell deployments that are getting 5G speeds in a house with no other kind of connectivity, that should be a huge problem for people. I love the aspirational aspect of this. Let's get to a gigabit per second. I don't think we're ever going to get there. And even if we do, I think it's going to be a small fortune because the amount of equipment upgrades that we're going to have to do to get there are problematic. But also think about this, the fact that Google Fiber is no longer doing like new active deployments like they were, that service was a huge driver to force service providers to do upgrades to keep pace with the opportunities that were afforded by that technology. Now that we don't have that, I mean, it's basically the FCC dragging and kicking and screaming into the future. So Chairwoman Rosenworcel will continue to sip a little bit of tea out of a reasonably sized coffee cup and make them do what they're supposed to be doing anyway, which is providing their customers with stuff that your customers want. I mean, how hard can it be? All right, Stephen. It looks like the supply chain has finally caught up to our suppliers because Intel has quietly begun informing their customers that there is going to be price increases. Now, they did mention this in their April 28th earnings call. However, it looks like D-Day or increase day actually is here. These are variable depending on the units that you're purchasing. Some of them saw a small, very light percentage increase. Some of them got like a 20% increase. I wonder if that's the ones that nobody's using. For now, these companies haven't, the price increases haven't really been confirmed and locked in yet. But we're seeing that that's probably, this is like the trial balloon to figure out if that's what it's going to be. Considering the number of compute products that Intel supplies for a number of people, are we really looking at a huge price increases in the coming months? And then the other thing to think about, Stephen, as we mentioned, have mentioned several times in the past, the U.S. Senate just passed the CHIPS Act. So is that going to have any bearing on whether or not Intel is going to be able to recoup some of these costs?
Yeah, I think that the important thing to think about here is that Intel is still the heavy hitter in IC manufacturing. Although we love to talk a lot about AMD and their wonderful, wonderful products, they still trail Intel in the marketplace dramatically when it comes to CPUs. And Intel also has the fab capacity, like, well, AMD doesn't make their own chips. So, Intel is able to do a lot when it comes to pricing. I think a lot of analysts expected Intel to basically just say, oh, yeah, AMD, and push prices down until AMD couldn't afford to compete. But that's not what's happening. Instead, Intel is raising prices, as are AMD and everybody else. And I think this comes, frankly, from more from inflation than from anything else. TSMC has raised prices for fab customers, Samsung as well. Pretty soon, I think Global Foundries did. Essentially, what we're doing here is adjusting to the current rate of inflation more than anything. And I think that there's sort of a tacit agreement among these big companies that they just can't fight on pricing when the cost of everything is going up, because it'll hurt everybody in the industry. And so, frankly, I think that what's going to happen here is that prices are going to go up across the board, but basically for inflationary reasons, not for competitive reasons. That being said, as you mentioned, the US Senate did just pass the CHIPS Act. Now, their CHIPS Act was a little bit different. Interestingly, most of the money in the Senate version of the CHIPS Act goes to fabs, not to chip designers. And that is really interesting, because what it means is that this basically means the US government caved to Intel's demands and is likely to give Intel the money they asked in order to get that Ohio fab and the rest of the new fabs up and running quicker. And yet, they're not going to support a lot of the semi development work that's been happening or might have been supported by this funding. So it's a really interesting situation here where the prices are going up anyway. The money is coming from the federal government. Intel's going to build their new fabs. And frankly, Intel wins. I think that that's the bottom line here from this story. Intel wins because they get the money they wanted, and Intel wins because they are able to build their new fab, make more product, and make even more money. Turning to a different FCC story, Tom, if the FCC thought that replacing hardware was going to be cheap, they obviously haven't gone shopping recently, as we just discussed. The organization announced that their proposal to compensate U.S. companies to remove Huawei and ZTE gear is now $3 billion over budget. The original approval was for just $1.9 billion, and the current cost is just shy of $5 billion. The overall funding commitment won't even cover the initial applicants for the service provider space. Then there's very little money left over for the second category of education and healthcare. How'd they miss the mark so wide here, Tom?
Because they underestimated how greedy service providers really are. I say that with a little bit of tongue in cheek, but it's absolutely true. As we mentioned up there before, the providers are going to give you the minimum necessary to give you requirements, and they're not going to want to spend any money unless they absolutely have to. But what's an even better solution than that? Can I spend somebody else's money to do this? Absolutely. I think what happened is that the FCC honestly underestimated the amount of penetration that ZTE and Huawei actually had into our markets. And I think a lot of service providers were using this as kind of an excuse to rip and replace some older gear that they would have liked to have gotten rid of anyway. So it's like, hey, if we have to get rid of this gear that was basically given to us by Huawei as a way to get into our market, might as well get rid of it while we can get paid for it. And then everything just kind of fell apart from there. So you got to think about this. Originally, Congress had laid out about $2 billion. And I know we talked about this in a previous episode of the Rundown, how they were thinking maybe that's not going to be enough. They got 2.5 times the amount of applicants that they were expecting. And mind you, I've worked with the some of the FCC's programs through things like E-rate in the past. Like tier 1 is like critical infrastructure. That's like service provider stuff. And they ate up all the money. We didn't even get to the schools, universities, libraries, hospitals, all of things you would think would be important, but are still in tier 2. They're getting like something like $280 million. So pennies on the dollar. Everything else fell into like tier 3. And there's no money for tier 3. And even the tier 1 stuff is like, it's about a third. It's like 35% of the companies that applied are going to get money from this. So what does it effectively mean? Well, it means that the service providers are going to foot the bill, because if it's illegal for you to have that equipment in your organization right now, if it violates government mandates, you're going to have to rip it and buy the new stuff. I also think that maybe some of what happened is that this hit at the exact wrong time in the hardware market, when hardware prices shot up because we can't get the equipment to manufacture them, or suppliers like Intel are starting to see massive runs on their inventory, so they're having to raise prices to compensate. It's like the perfect storm of, we're telling you need to get rid of it. All of the stuff that's available on the market is more expensive, and we didn't put enough money into the coffers in order to be able to afford all of it. And so now you're kind of faced with this choice of, do I continue to violate the law but not spend a whole lot of extra money, or do I spend the money that I have and replace the pieces that I can, knowing that I'm going to have to take another run at this in a couple of years when either that equipment fails or somebody finds this out? And that's a common problem when you're using government money to solve your solution problems. And it got so bad in the E-rate program about a decade ago, before I finally got out of it, that you had these crazy rules, like you were only allowed to take equipment 2 out of any 5 years. The rest of the time you had to use it to pay for services, or that you were very restricted in the category of the equipment that you could use, or a whole bunch of other things that felt like jumping through hoops. And yeah, I understand that the government has lots of red tape that you have to deal with, and you have lots of checklists that you have to basically, hit all of the boxes for you to be able to get stuff. But the flip side of that is that when you have companies like, oh, we had one Huawei router in here, that means we get to replace all of our equipment because it's old and we want to spend the money. You can see why those checkboxes exist. So I don't think that there's a good solution for this, other than to maybe give companies a grace period to let prices fall back down before they're required to start ripping and replacing that gear. But unfortunately, it looks like giving them money to do it isn't going to be the best solution, because there isn't enough money to make it happen. All right, Stephen, one more story here that I thought was kind of an interesting one. We're all familiar with chiplets. They're the technology that seems to be taking over the CPU space, especially in design in 2022, because they're effectively little specialized units that perform at peak function. And it could allow us to break through some of the barriers that we're starting to see in CPU design, like upper limits of speed, heat issues, so on and so forth. The question, though, is how do you connect all those little chiplets together? And you want to ensure that those aren't the bottlenecks, because that's not something you can fix after the chip's designed. Well, the Open Compute Foundation thinks they may have found an answer. They released their new BOW specification this week. Well, what does BOW stand for? Well, it stands for bunch of wires, which sounds like some old person's approximation of how the internet works. I'm sure there's a bit more complexity to it than that, because it has diagrams for the proper way to have all these copper wires laid out and new phi layers. But Stephen, why is the BOW standard such a big deal?
Yeah, I think this is really interesting. So, first of all, let's just point out that there's a ton of interest in having some kind of standard interconnects between chiplets. And frankly, there are a ton of different approaches to doing this. So, everybody is starting to look toward chiplets as a way to improve chip performance. And I guess maybe we should start with that. What the heck is a chiplet? Essentially, historically, a microprocessor, an integrated circuit, was a single, basically a single die. Everything on there was etched at the same time on the same, slice of silicon, and then sliced off and put in a package, and the package is sold to integrator and eventually to you. And so if you bought your Pentium PC or whatever it was basically that was the thing. Well, a few years back, some companies decided, what if we actually took multiple pieces of silicon and integrated them into the same device? And this is actually not a super new idea. It dates back quite a ways, but the idea is that way you can have specialized um, components for different things, all in the same chip, all in the same integrated circuit package. And this also gives us an opportunity to kind of go into the chip design world, because, as you know, there are different architectures, geometries for chips, and they have different performance characteristics, and also importantly, different costs. And so, for example, you may want to have the highest performing, tiniest features on your high performance core, but maybe your static RAM doesn't need that, or maybe a support chip doesn't need that expensive foundry. And so what you can do is you can basically take components away, put them on different chiplets, and then put them into the same package and then ship that package. And that's a very, very popular thing. It's pretty much everywhere. Apple has made hay with their M1, but it's not just Apple. And in fact, Intel is already going in this direction as well with their mainstream CPUs. They just announced that. So we're going to see some really cool, what they're calling tile-based architecture, where essentially you can have a chip that has various different chiplets on it that do various different things. So maybe this one's got, I don't know, 3 graphics chiplets and 1 CPU. Or maybe this one's got all 4 CPUs. And so you can do all sorts of interesting things. The challenge here with chiplets is that it's all proprietary. And there's all sorts of different ways of implementing it, from what are called interposers to bunch of wires, which is pretty much what it sounds. So the interposer is a more of a smart way to interconnect these things. And essentially the industry is trying to figure out how they're going to do this. Now, open compute is a really interesting angle here because, as you may have heard, when it comes to system design, this is driven by the hyperscalers. And essentially, they want a high performance server that allows them to kind of plug and play different components, whether it's the very, very popular Open Compute Networking standard or the rest of the design of the server. And now Open Compute is saying, hey, we want there to be a standard for the simplest form of chiplets using a bunch of wires spec. And essentially, you can imagine that this thing is pretty much what it sounds like. It basically says the wire from this position goes to this position, and this position goes to this position, and these make a slice, and that slice has so much throughput. And then you can take chiplets from different companies even that do completely different things and mix and match and build your own CPU. Asterisk if you are a giant hyperscaler with gigabucks to spend on this thing. And that's pretty much what's going on here. Open Compute is going to have their bunch of wires spec, and I imagine that a bunch of interested companies, I don't know, just to guess, I would say companies that are making ARM and RISC-V CPUs, companies that are making accelerators for machine learning, that sort of thing, are going to be developing chiplets that can be used tiled into this bunch of wires spec. At the same time, though, the rest of the industry is also developing specs. There's a spec called UCIe, which has companies like AMD and Intel and ARM and, yeah, Google Cloud co-developing a chiplet interconnect as well. And so there are other standards, there are other options. This is not going to be the one standard to rule them all. But I think eventually what we're going to see is standards emerge for different areas. So there's going to be a standard for high bandwidth memory and a standard for chiplet to chiplet interconnect and a standard for IO and all that kind of stuff. And it'll all settle out. But for now, it sure is an exciting world of chip design.
Who would have thought we would have ever said that chip design is super exciting? Well, except for chip designers. We have a couple of stories we want to take a closer look at. They both kind of have a theme around security, so I thought it would be interesting to kind of see where we're at in that space. And the first one that we're starting off with is actually something you may not even be aware of, because attackers are starting to target critical infrastructure that runs industrial and manufacturing facilities. Now you're probably thinking to yourself, wait a minute, that doesn't really sound like a new thing, right? Well, you're right, except the fact that it's getting faster and there's a lot more sophistication involved. Security firm Dragos has noted in a recent post that there has been a significant increase in the number of people using password cracking tools on industrial equipment like programmable logic controllers. They're called PLCs. This genius really comes into play because they're not cracking these PLC passwords in order to do things like wrecking these giant milling machines or doing other stuff like that. No, they're just turning them into nodes in a giant botnet. You know, that thing that we do sometimes where we amplify a whole bunch of extra stuff. Yeah, if you think it's hard to clean malware off of a PC that you can just shut down and reboot it 4 or 5 times until you make sure that you got everything cleaned out, imagine how hard it is to do that to a machine that has to run 20 hours a day and never goes down and takes 8 or 9 or 10 or 12 minutes to reboot every time you do it. Oh, and it doesn't have a screen either. That can be rather difficult. Dragos has noted that while they only tested one kind of PLC in this little blog post that they wrote, they took a sample of some other ones that were from different manufacturers, and they all showed signs of having malware already. Stephen, do you think it could cause problems for our supply chain if our industrial and manufacturing machines are suddenly nodes in a giant botnet?
Yes. Next story? Oh, I'm kidding. Um, yeah, this is some crazy stuff. Effectively, just kind of for background here, PLCs are not servers that are used for industrial automation. These are more like industrial IoT. Essentially, they're small, lightweight systems that are designed to run all sorts of industrial applications, from robots to heck, lighting and air conditioning and power. These things are so important. Effectively, the modern factory is a wall of PLCs that are each controlling a thing that does a thing. As you can imagine, efficiency of a modern factory is pretty high because, frankly, those little things that do a thing are really good at doing that one thing. But if you're asking them to do something else, like, I don't know, send out a DDoS attack on some website over HTTP, they might not move that robot arm the right way, or they might not move it quickly enough, and that could cause all sorts of issues. As you can imagine, too, if they can be used in a DDoS, even if it's not interfering with regular activities, think about what could be done to turn these things off or to mess things up. I mean, we've already seen PLC attacks on Iran and their nuclear capability. I mean, imagine doing the same thing on, I don't know, General Motors or heck, Tesla. They've all got tons and tons of these things, and you could basically take down a whole factory by turning that DDoS on itself. This is just bad, bad, bad. But it's predictable, isn't it? Because frankly, what you've got here is you've got a system that has very little maintenance, very low skilled, and I say that from an IT perspective. These people are incredibly skilled at programming PLCs, but they're not highly skilled in terms of cybersecurity, like that kind of skills. Operators, and in fact, one of the roots of this attack came down to the fact that people were basically quitting one factory and walking away, and nobody wrote down the passcode. And so somebody had to hack it to get into the passcode. And then they said, oh, wait, if it's that easy to hack it to get the passcode for recovery purposes, oh man, what else could I do with this? Anyway, yeah, this is bad, 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 Tom.
And I think it's interesting that you bring up the Iranian PLC centrifuge issue with Stuxnet, because that was, well, how do I put this gently? That was subtle. Like that was a very specially crafted piece of malware that was designed to do something extremely insidious that made it very, very difficult to trace back to A, what was causing the problem, and B, how to fix it. That was the James Bond Aikido judo method of making you beat yourself. These guys are a little bit more like Henry Hill from Goodfellas. They're just going to punch you in the mouth, and that's kind of what I'm worried about. Is when you look at the fact that they don't care if they're attacking PLCs. Like ultimately what they're doing is they're basically doing like John the Ripper attacks against whatever's in your organization. And if it happens to pop a PC, or I don't know, like an access point or a PLC, almost so much the better. Okay, my little framework says that I can deploy this package to that thing, and it gives me an extra, I don't know, 50 megabits per second on my DDoS capabilities. Woohoo! Now I have the biggest botnet in the world, and I can, wipe out people who are, I don't know, beating me at Fortnite or whatever, because that's honestly what a lot of these things turn into. Or they're renting it out to people. But where the problem comes into play is when these people get burned. And we've seen this time and time again. When the proprietors of these rentable botnets start getting caught, they burn it to the ground. And that's where the real problem comes into play. Because if I hit the kill switch and it just suddenly decides to stop everything that I'm doing, you wipe a PC that is currently, like, oh, hey, we weren't smart and we left the records on the PC instead of keeping them in Google Cloud or something like that. I can go get a backup, right? That's the hope. I was time machining my data. When you wipe a PLC, unless you have somebody there that can reprogram that thing on the fly, or you are under warranty or something like that, it's gone. It's wiped out. And that machine is losing money every minute it's not doing what it's designed to do. That's a problem for me. And I think that that's one of the things that a lot of people are trying to solve by not necessarily trying to make these devices industrial IoT enabled themselves. But I know like companies like Cisco are actually front ending them with like these small form factor switches that are more IT friendly for the people who manage the IT. And so what that means is that you have a consistent interface that's also a lot harder to hack, because it doesn't have that specialized, like the article that Dragos put up, like the passcode of this PLC was just like a 7-digit number. Well, John the Ripper can probably find the digits for that in like a day at worst, if it has like a rate limiter or something like that. So by putting, say, like a Cisco Industrial IoT router in front of it, you're hitting a wall before you ever get to the device, and the device doesn't know any better. So I think that's probably going to be a better solution going forward, because those are more manageable devices than these tiny little things that are so hard to program that they require super specialized knowledge that's non-IT.
Well, Tom, we have another story here that's pretty related that I want to bring in as well, and that's smelling a rat. if your SMB or SME devices are vulnerable to a new attack, well, you might be smelling a rat. Lumen Technologies has announced a wide range of devices from multiple manufacturers have been infected with what's called ZwoRat, a remote access Trojan that has been in the wild since late 2020. The particularly nasty part of this malware is that it targets MIPS processors, such as the ones found in SMB and remote office routers. Sound familiar? Gear from Cisco, Asus, Netgear, and many, many, many other companies has been observed to be compromised. And ZwoRat is also leverages a point to load more nasty things into the data stream. It can infect Windows systems on the inside through DNS hijacking and man-in-the-middle attacks. Lumen was able to track a cluster of these infected devices back to command and control servers overseas. And the current fix is to reboot and clear the infection and factory reset the device as well. But here's another set of small systems that are being targeted, and systems that don't generally have great systems administration.
And that's part of the reason why I think that they're targeting them, if you want to be honest with it. Because, like, think about it. If you could figure out how to, I don't know, hack the Gibson or hack a CRS1 or CRS3 in the core of a service provider network, think of all that bandwidth that I could use to pump out these attacks. Well, instead of hacking one big router, why don't I hack 10,000 little ones? And that's the essence of a distributed denial of service attack, right? And when you have these little edge devices that are running MIPS processors, which are like sub arm, like they are just barely fast enough to keep the lights on, quite literally. But if you've specially crafted this malware to be able to exploit holes, those are things that don't get patched very easily. Like the Mirai botnet was taking advantage of these ODM manufactured cameras that had a security hole, and when they reached out to the ODM that wrote the software, their response was, "We're not fixing it. Like, that guy left, or that's not there's not enough money in us to put out a patch for that." Like, that's the problem you're dealing with. Like with a company like Microsoft or Cisco or IBM or anybody who's a large manufacturer, even if the system's out of warranty, or like it's getting close to end of life but it's still in support, they'll create a security patch for you. If you bought like a Netgear router like 3 years ago from a big box store, and the processor won't take another system upgrade, they're not going to write a custom patch just for you. And so that's part of the problem, because it's a vicious cycle. How do you fix the problem? You reboot the device. When you reboot the device, you probably need to factory reset it. So just back up the config settings and reapply them. But if you didn't patch the hole, you're going to get reinfected again. I mean, all you got to do is go to Shodan and you'll know how many of these devices are out here with specific vulnerabilities. So then it gets into this game of what's going on. But the part about ZwoRat that really scared me in the Ars Technica article that we linked to, it's not just that you're turning your edge router into an amplified DDoS machine. It's what it can do to the packet stream coming into your device. So you may be running all of the latest antivirus and have all the stuff and think that you're not infected. And then something hijacks your DNS and suddenly Cobalt Strike is dropped on your computer. Well, guess what happens? Reboot the device, the Trojan ZwoRat goes away on the router, right? You still got Cobalt Strike. Now what are you going to do? Because you have an infected PC that you're going to have to deal with, and it's going to keep infecting things inside of your network. So it's a low effort, devious way to create even more amplified traffic for these botnets. And when you've looked at the number of people who have been getting like hundreds of terabits per second in their botnets, that's frightening. Like, that's not just like a little bit of a packet stream that we can use to knock things offline. That's effectively the Archimedes death ray of DDoS attacks.
Yeah, and I think that it's important to remind everybody that a lot of these products are, well, frankly, these chips are everywhere. Myself have a number of MIPS routers. I mean, heck, we run a router at Tech Field Day that theoretically could be exploited by this attack, and hopefully the vendor is going to update it to protect it from this. Definitely going to probably be reinstalling that occasionally. But we're computer security professionals. Most normal people are probably still running the original software that came on their router when they took it out of the box, and most of them are continue to run that. And frankly, I think most of the people who own these routers, just like those industrial control systems we talked about, just like pretty much any kind of IoT device, most people that own them, run them, are not savvy enough to update them, even if there is an update. And they're not driven to update them. They may not even know something's going on. I mean, can you imagine DDoS running on your, I don't know, your cousin's home router? They might just think the internet is a little slow. They would never know. Maybe the first alert they would get is if their ISP said, "Hey, you used so many gigabytes of data last month. What's going on?" But even there, they would have no idea how to fix it, and neither would the ISP probably. So it's really really bad, and it, combined with the attacks on industrial IoT, combined with the attacks on PLC controllers, combined with the attacks on basically unsavvy, unsophisticated users' devices. Which, to be honest with you, why should people be savvy and sophisticated about technology that they're using casually? Um, all these things are pretty terrifying. And frankly, if I can editorialize here for a minute, I think that this is one reason that, frankly, a lot of the competition regulations that are coming out of Europe and the United States, opening up app stores and things like that, I really think they're going in the wrong direction. I would much rather see strong support for devices from manufacturers, even if it means sacrificing competitiveness in terms of the cost of apps or app stores or payment processing systems or whatever. One of the things I like about the Apple ecosystem is that they, at least theoretically, do some review. Now, their review kind of stinks, but how about this? That they can shut stuff down if they need to, and that they can push stuff out. On the other hand, I really would like to see more intervention and push toward forcing companies to provide at least some kind of long term support, or liability at least, if their systems are compromised. Because frankly, a device that hasn't had an update in years is just ripe for a compromise. And if a vendor isn't going to support that or doesn't support that, yeah, we can vote with our dollars, but frankly, we're voting with our dollars when we buy the cheapest possible devices, and then see where that gets us. For another reference, check out the recent hack of GPS tracking devices for vehicles this week. It all points to people basically buying cheap garbage and then being shocked when the things get exploited and there's no support available for it. I think that's the marketplace at work too. So, maybe it's time for some kind of government intervention here.
Well said, Stephen. That'll just about wrap it up for the rundown this week. We do have something coming up in ahead that we'd like to let everybody know about. August 3rd and 4th, we're having the next edition of our networking field day focused on service provider technologies. You can find a little bit more information about that event by going to techfieldday.com. You can find a list of the participating companies as well as the delegates who will be there. As always, if you want to find out a little bit more about the cool technology that we're hearing about, you can head over to gestaltit.com and see the articles that we're writing up. You can also listen to our on-premise IT podcast, and you can check out some of the other cool things that we're doing, including every episode of The Rundown, which will be coming out every Wednesday right around 12:30 Eastern Time. You can also subscribe to us in your favorite podcast application of choice if you prefer to get the audio version of what we're talking about. We'll be back next week with another episode of The Rundown. And as always, if you have any stories that you'd like to see us cover, please make sure you tweet at Gestalt IT. Use the hashtag Rundown, and we'll take a look at it. And you might get some credit in the show notes as we talk about something cool happening in the world of technology. So for myself and for Stephen Foskett, hope you enjoy National Fortune Cookie Day. And signs point to us seeing you very soon.
And actually, on that note, Tom, wouldn't it be cool if we did the rundown together in person?
Ooh, that does
Let's try
sound
that
interesting.
sometime.
You know what? Let's book it for next week. Next week, Tom and Steven doing the rundown in the same room. I bet you can't wait.